Get it going. Okay. So, all right, now that we're finally getting started. So what we'll talk about today, I guess let me just go ahead and get right on into it. This is CSE 313 System Administration. We're going to continue our discussion on file access, and we're going to get into, I had hoped that we would be able to complete the chapter on processes, but I'm not positive that will end up happening today after all. But we'll see. We'll see how much time we get to and what we're able to do today. So let me go ahead and get up with the file access chapter. Again, this is, well, of course, it's not signed in yet. After the restart, I guess it signed me out. Okay. So what we'll do is we'll go ahead and pull this up. Yeah, managing file. Okay, so one of the things you'll notice here is, let's see, this chapter, this page that we're on, this managing file system permissions, it's actually where we ended last week, and we finished through this, but I feel like we kind of rushed through it a little bit. So what I want to do is I want to go over this again, because really, as far as what I would say is, as far as chapter 6's content is concerned, this middle section, this managing file system permissions, is really important that you understand it. So I do want to go back over it again so that you guys can see it again. All right, so again, the way that we can change permissions on a file, because this is what it's all about. This is what, in some ways, what system administration is all about. Is about managing control, is managing who has access to what, who can change a file, who can read a file, who can do things to folders and stuff like that. Because really, even down to core system files where passwords are stored, where user information is stored, controlling who can change that can control who has access to the system at all. So if you somehow give write access to the two files that we talked about that control what users are on the system, that store what users are on the system. You remember the Etsy password file and the Etsy shadow file that we talked about? If anybody on the system has write access to those files, they could really wreak some havoc on your system. They could create users when maybe they shouldn't have the rights to do that. They could change passwords when they shouldn't have the rights to do that. They could lock other people's accounts, right? So that file, those two files right there, along with a whole load, a whole ton of other system files, we need to be able to control access to, right? So here, this section talks about how to control access to these things, right? So again, the format that we use, the command to control and access, to change mode, to change access, is the chmod, right? And then it kind of follows this who, what, which format. This who, is it the user? Are you changing it for just the owner? And the user is the owner of the file, the user owner. Or are you changing it for the group, which is the group owner of the file? Right? Which, remember, when we first create a file, the owner, the user, is the person that creates the file, as we would expect. The group owner for that file is the primary group that user belongs to. Okay, but we can change that. We can change who the owner is, and we'll get into that. I think we got into that actually. Anyway, so the O is for other, for anybody else. Now that's not just other as in, any person could just walk up to a computer on on our system and be able to access a file, it means other people who are on that system, right? So they still have to have a user account, the stuff like that, right? If they have access to the system in some way, O stands for them, okay, other. If they're not part of the user, if they're not the user owner, if they're not part of the group that owns the file, if there's something else, that's what they get, okay? Now, we can add write permission or read permission or whatever. We can subtract it, we can remove it, or we can set exactly, okay? Most of our examples are going to be these two, adding and removing. Setting exactly, we don't really see that a whole lot. Okay, and then finally, R, W, and X is, do we want to add or remove read, write, or execute permissions? Okay, all right. Then again, we also talked about this numeric method for doing it as well, where 4 is for read, 2 is for write, and execute is 1, where it's the sum of those. So if we want to give, this would be in the order user, group, other. If we want to give the user read and write but not execute permission, we would give them 4 plus 2, which is 6. So this number here, this first number would be a 6. Okay. If we wanted to give the group read-only permission, we would put a 4 here. Okay. And then finally, for the last number, if we wanted to give other people no permissions at all, we would put a 0 here, and then they would get none of these. They wouldn't get read, write, or execute permissions. Okay. Hopefully, those of you who have been paying attention to this, hopefully you recognize that this is basically binary, right? So this is and I wish I could write on here, but I can't. But this is basically 4 is binary 1, 0, 0. 2 is binary 1, 0, and 1 is binary 1. Right. So basically, it's, if we think of it, read, write, execute as a 3-digit binary number, if we want to give permission in a category, and read, for example, we put a 1 there. If we want to not give permission in a category, we put a 0. And then we just take that binary number that we get. So again, back to our user example, 4, 2, that would be 1, 1, 0, because we're giving read, we're giving write, we're not giving execute. So 1, 1, 0. And what is 1, 1, 0 binary when we convert it into decimal? 6. So then we would put a 6 here. Okay. All right. So hopefully that's all pretty clear. All right. So again, we're going to look at some examples here. What we'll do is, assuming that I can get the whole virtual machine up and running today, it doesn't seem like much stuff is going my way today, but if we're able to get that virtual machine up and running, then I'll go through this practice here with you guys. All right, but if we want to change the permissions on a file, so this would, again, the group and other, we're taking away read and write permissions from file 1 for them. Okay. We want to add an execute permission for everyone, for A, for group, for user group and other, for everybody. We're changing the mode to add execute permission to everyone. Okay. Now we can set exactly permissions. So this would take this directory and it would give read, write, execute permission to the user, to the owner. It would give read and execute only permission for the group, and it would give no permissions at all. So no one besides the users or the groups would be able to get into that directory, would be able to see the contents of that directory. And we can also use this minus capital R, this dash capital R option to be able to recursively set those permissions for things inside of that directory as well. All right. Now, we did talk about this. That's part of this section. That's right. So here, we can change the permissions based on the owner and the group. But what if we want to, again, change the group or change the owner? What if the file was created by somebody named student, for example, but we want to change the ownership to where not only can student view it, but also other people who are part of a group that student may be a part of, or even a group that he's not a part of, he or she's not a part of. Right? So we would do this through the chown command, the change ownership command, right? Where what happens is we take this, right, and we say, now we're going to change the ownership. File comes here last. What file are we changing the ownership for? And who are we giving the ownership to? So we have changing the ownership to this person of this file. Okay. So whoever owned it before. Now, it's possible that the person who owned it before loses all access to the file after this happens. That could happen depending on how the file permissions are set up. It's also possible that nothing changes about how they're able to view the file based on the group permissions or the other permissions. Okay. So I'm realizing I should have put a question like that in about if we change ownership of something, about how ownership changes in the homework assignment that I gave you guys. Yeah, maybe that'll show up on the exam. Okay, so the idea though is if we change the ownership for a file, the only thing that changes here in this example is who the owner is, who is considered as the user owner of that file. Okay, right now. Same thing with directory with that -R option is we can also set the owner of everything inside of it to be the same person as well, same user as well. If we want to change the group owner, we just put a colon in front of who the owner is going to be, and that changes the group owner. And as we talked about last week, there is a possibility you can do them both together. You can change the owner, the user owner, and the group owner at the same time by putting user owner : group. Okay. So now after this command is run, this directory has a new group owner of guests, has a new user owner of visitor. Okay. All right, so right. So only root can change the ownership of the file, which means we have to get root, we have to get super user access. We talked about that in the previous chapter. So root will have to be used to change the ownership of a file. Now, group ownership can be set by root or the file's owner. So if you are the file's owner, you can change who owns it, who owns it at the group level. Otherwise, if you're not the owner of the file, root will need to be the one to change the group owner. Okay. All right. Oh, and also non-root users, so just regular users, can only grant ownership to groups that you belong to. So you cannot give ownership to some other group that you're not a part of. Okay. All right. But for the most part, when we go around changing ownership of files, whether it be the user or the group, we tend to run those as root anyway, using either the sudo command or switching, or the su command to switch into the root user. All right. Okay. Again, we will do this practice. We'll do this practice we'll do a practice like this, I should say, because I don't have access to this online Red Hat version anymore. So we will do a similar thing to this in the practice, and I'll show you how to do some of these changing permissions and stuff. Okay, all right. And these practices for chapter 6 and chapter 7 now are in that folder, that class materials folder. Okay. All right. So, all right. What about managing some default permissions? Okay, this is some fun stuff, right? Now, all right. Okay. So when we run a command, okay, we run the command as the user or the group of the file. Right. So when we run the password command, so if remember what I said earlier, okay, what I said earlier was if you give permission to the Etsy password file and the Etsy shadow file to just anyone, let's say we give read, write, execute permissions to all, to other, to user, owner, other, user group, other, okay? Then that would be a really big problem because what would happen? You would have a situation where anybody could change that file, right? But I imagine for some of you who are sitting there thinking to yourself, well, wait a second. I can change my password without being root. Isn't that stored in the Etsy shadow file? So aren't I changing the Etsy shadow file? But I don't have write access to that file, do I? And you're right. You don't have access. If you're a normal user, if you're not the root user, you do not have write access to the Etsy password or the Etsy shadow file. So how do you change your password? How are you given access to change your password? Well, when you run the password command, so this would be this user bin, by the way, binary. That's where all our commands are stored. To run a command, it looks for it in this user bin folder. Okay? It's a file that exists. It's a binary file, an executable binary file that exists inside of the user bin folder. All right. So when we run this command, even though I'm running it from, say, student, even though I'm running it from student, it runs as the owner or the group of the file, not as student. Okay? So it can be a little bit tricky to understand, but when student runs, it does not run that command as if it was student running it. It runs the command as if root was running it, because root is the owner of that file. So what does that mean? That means that when root runs that command, guess what? Root does have access to change the Etsy password and Etsy shadow file. So when that command is run, because you are running it as root, because the command is being run as root, then the that gives access to be able to change that Etsy shadow file. All right, so some other special permissions, the sticky bit, that's this this last part over here. All right, that's where this T that's highlighted here means read write T. Right, so it's a special restriction that only the owner of the file and root, if it's not root, can delete files within that directory. So the temp directory, only root and the owner, which is also root, can delete files within that directory. So even if you may have access, for example, here on the temp, you have access as other to write and to write, right, to that directory to change things, which normally would allow you to delete things inside of that directory. Here, because this T is there, that means that only root is allowed to actually delete files within directory. Okay. All right. So we can set the if we have a set GID, all right, set group ID on directory means that files created in the directory will inherit that group affiliation. Okay, so basically, when we create files, instead of giving the group as the user the primary group that user belongs to, it'll just inherit from the parent directory instead. Okay, I hope that's clear. That when we have that set GID on a directory, that can change kind of how files inside of that directory is created. Okay. Okay. So, and basically this is the same. So this is you're adding special permissions. So when we look at the examples here, it's the same as the change mode, where we are adding the set GID to the group, the SGID. Right. So what does that do? We're adding set GID bit on a directory named directory. Okay. And the same thing is true here with this whole, so we can do this numerically, that if we add this fourth digit in front here, then we're setting the set GID bit. All right, that's what this fourth front digit does for us. Okay, same as but with the read write execute is being added for the user and the group with no permissions given to other. All right. So let's get into how do we find out and set what default file permissions are, because this is what every time that we create a file, it will be given default permissions. And the way that we find out what those default permissions are is using the umask command. Okay, so when we look at umask, when we type in umask into our terminal and we hit enter, we will get this 4-digit number out. Okay. Now what this tells us is how the permissions are granted to any new file that gets created. Okay. Now, the thing that's going to be a little bit confusing here is this is the opposite of when we set permissions on a file, doing it numerically. A 1 we look at each of these digits again as a 3, each digit as a representing a 3-digit binary number from 0 to 7. Right? Then a 1 in a position now means don't give that permission. When we were setting permissions before using the change mod command, the chmod command, a 1 in that position meant give the permission. So it's a little bit confusing, but now when we look at the umask command, a 1 in a position means take away that permission, block that permission. A 0 in a certain digit in a certain position means give that permission, let it pass through. Okay. So if we have a umask, for example, of 077, right? When we create a new file, it means give all permissions to the user owner, read, write, execute, give all permission, but don't give any permission. Block all permissions from everybody else. The group, the other should not get any permissions. The owner, the user owner should get all permissions. Okay. So what does that mean for this umask of 002? What permissions will be granted? What permissions will be blocked? I actually would like you guys to comment on this, for a couple of you guys to maybe say, what do you think? A umask of 002, just look at the last 3 digits. Don't worry so much about this first one just yet. But a umask of 002 means when I create a brand new file, what is its default permissions going to look like? What permissions will be granted? What permissions will be blocked? Okay, write permission, but which on who? Who is that granted or blocked? Is it granted or blocked, and for who? Okay, so group and others will, you're saying group and others will get write permission, and the user owner, what permission will the user owner get? Hmm. Okay, so it looks like you guys are having a little bit of difficulty with this. So let's go through it a little bit more. So thank you, Nita, for either having the courage or perhaps that you're paying attention. I don't know, but thank you for responding. So let's go through it again. Let's talk about it a little bit more. So when a 1 is in the position here, then that means that not a 1 decimal number, but a 1 binary. Then that means that what is it? Then that means that that permission will be blocked by default. Okay, so let me see if I can pull this off. Let me see. I want to, you know what? Hold on, let me do a whiteboard. Pull up a whiteboard and see if I can do it this way. That's what I'd like the most. I think it's better. It's maybe if we can draw it out and show you guys, and that will help. Oh, should I wait to eat this? Oh. Okay, let me go ahead and share this with you guys. Why is it not sharing? Oh, this whole thing. Okay, so here we have my whiteboard up. All right, so here let's. There's not a way to write text, is there? Okay, whatever. So here we're talking about the U mask, right? Now, each of these numbers, so it's 3. Okay, so let's again talk about that as 3 different numbers that each represents a binary, a 3-digit binary number. Okay, so it's read, write, and execute. Now this shouldn't be anything different. So far, we haven't said anything different from when we look at the file permissions or when we try to set file permissions using the change mode command, the chmod command. Right. Now the difference though is a 1 in a position means block access. So for UMask, when a file gets created, the default is a 1 in a certain position means block that access. Okay, so a 0 in that position means allow that access to come through. So let's talk about what a UMask of 0 0, 2 means. Okay. So that means here, this digit means for the user, right? This is for the group, and this is for all others. Okay. So what is a 0 in binary? A 0 in binary is 0, 0, 0. Okay. So this means that for users, when we create a file, for my user that I'm currently logged in as, when I create a file, my default permissions, or file or folder, my default permissions will be read, write, execute. Because the 0 means let that one go through. 0 means let that one go through. 0 means let that one go through. This 0, same way, 0, 0, 0. So I will get read, write, execute. Okay. Oh, we got to a different value. Now 2 in binary is what? 0, 1, 0. All right. So now what this means is read, I'm going to pass through. I'm going to let it pass through. Write, I'm going to block. And execute, I'll let it pass through. Okay. So what this means is that, let me switch over to a different color. A UMask of 002 means that when I create new files, this will be the default permissions that will be given. When I create new files and folders, this will be the default permissions that are given. Okay. The 2 here blocks write access. Okay. All right, so let's go on back to this guy. All right. All right. So notice here when we create, so our UMask was 002. When we created this new file 1, what happened? When we look at the permissions for it, read, write. Now, I know somebody out there that's watching this right now saying, whoa, wait a second. You said execute was given. Okay. Here's the thing. With new files that are created, because files by default when they're created are not expected to be executable files, the execute permission is not given by default, even if the UMask allows for it. Okay, so files will not be given execution permission by default. Directories will be if you see it here by default, because it is because the execute permission means something on a directory. Okay, all right, but back up to this one. So we allowed through read write permission to users. We allowed through read write permission to group. We blocked write permission for other. That's what our UMask does. It's better seen again here in a directory because the execute permission is given. A new directory, by default, read, write, execute all allowed through. Read, write, execute all allowed through for groups. Read, execute, but write blocked for others because of our UMask, because of our default permissions. Okay. All right. Now, if we change the UMask value, which we can do, UMask gets changed to 0. We create a new file. Now, what does that mean? UMask of 0, 0, 0, 0 means we're going to allow all permissions to everybody. When we create a new file, notice all these permissions, all of them are granted. Okay. We can change the UMask value to 007. That means we're going to allow all permissions for users and for groups, we're going to block all permissions. We're going to block all permissions for other. And here, when we create new files, look, read, write, given, everything blocked. Here, read, write, execute, given, read, write, execute, given, everything else blocked. Here, it's another example. Give all to users, block write to groups, block everything to other. And that's what we see here when we create a new file and a new directory. Okay. Now again, umask as a command on its own, if we just type umask and run it, where is it? Right here. We get a response back that tells us what our umask is, what our default settings are. Umask with a value sets it. Now, it doesn't set it forever, it sets it temporarily, and we'll see how that works in just a little bit. Okay. Right. But it does not change it. The only way to change the mask value permanently is to go into one of these two files, the etc bash rc file and the etc profile file. These are default umask privileges, right, for different types of users. So here, the etc bash rc file tells us what the default umask is for users whose user IDs are greater than 199, and it has this other condition as well. What this should tell you is that this is for above system users. Remember, the 199 and below, especially you should know who the user ID 0 is, right? Those guys have a separate umask value. Us normal users, everybody that's 200 and up, we get a different umask value by default. Okay? So the default umask for unprivileged users, non-system users, right, is 002. The default umask for privileged users, for system users, especially for the root, that's the one that we're really interested in what happens with the root user. Their umask is by default 022. If we change that in the file, in the bash rc and the profile file, if we change those umask values there, they're changed permanently until we change them again in the file. Okay. So if we can change it in the file, we change umask to 007. If we change it temporarily, we log out, we come back in, and guess what? The umask goes back to where it was before. If we change it in the file, we log out, we log back in, and the umask stays whatever it is in the file. Okay. So again, I think that this is one of those things that we could probably see better through an exercise. So we'll look at some of that. Okay. We'll look at some of that as an example. I will try to figure out, I realize that the lab, you guys don't have access to this whole lab permission setup thing. I would like you to go through some exercises with this, so I'll figure out how to do this for you here. This week I'll get you some way to set that up so that you can play around with it and see how changing the mask stuff does stuff. Okay, all right. Moving on to chapter 7, talking about processes. So these two things that we're talking about, controlling access to files. So chapter 6 here, controlling access to files and managing users and stuff like that, managing ownership of files, and managing processes. These are some important topics. So I did not want, of all days for the computer to have problems today is really just not a good day. So because this is a very important topic. So we're not just going to rush through it. If we don't get done with this today, which it looks like it's likely that we won't be able to finish this chapter today, we'll definitely make sure to pick it up next week. Okay. All right. So a process is simply just a running instance. Like it's just a piece of executable program that happens. Okay. If you guys have done any, you guys I think have probably done some digital systems coursework. This class I think replaced the computer architecture class that would have normally been running in this place. And I would have taught that as well. We would have also talked about processes in that as well. But the idea is that a process is going to have some address space, some allocated memory for the stuff that it's doing. There'll be security, so including who owns it, who's running it, right? The process state. So what is the state? Is it running? Is it paused? Is it doing something else? And so when a computer is running, okay, now these days almost every computer that we run on, that we do anything on, does some level of parallel processing. If you talk about having multiple cores in a computer, it means that each of those represents a processor that is running its own stuff, that it's going to be doing things in parallel. Okay, but each of those processors is on its own is not a parallel processor. So each of them is running a process, and then the process will do something. It will either execute to completion, or it will pause to allow some child process to do something. So if you think of this in a way, kind of like a main program or a method doing some things, and then calling another method. In a sense, that's kind of what's going on. It's not exactly the same, but it's as close as I can get to explain it right now. And so the idea is that this process may need some other process to do some things for it while it waits. So it's going to fork off onto the child process. The child process is going to execute and do some things. It's going to finish up. The child process is going to finish up, exit back, and the parent process will pick up where it left off. So again, if we think about this as a main program or a parent method calling a child method, while that child method is executing, is doing whatever it's supposed to be doing, that parent process, that parent method is waiting. We don't continue on executing more code. We wait for that child process to complete. It may send information back to the parent process, and then the parent process continues on. Okay. All right. So, and we can see what we'll talk about here is in watching is how different processes can be seen as they're running. We can watch them. Okay. One thing, as far as the parent of the child is concerned, when it's done executing and it goes back to the parent, the control goes back to the parent, that child is considered to be what's called a zombie. Okay, so, I know zombies are very popular right now with different television shows and movies and stuff. In a sense, basically, it's there. It's still taking up space, right? It still has its allocated address space, and it's doing, and it's using resources, but it's not doing anything. It's done with its processing, right? And so it's just waiting for the system to do what over here, what is called reaping, which means taking it back, right? Taking back all those resources so that it can be used somewhere else. Okay. Now the parent, what it's going to do, one of its jobs is to clean up whatever was from the child. Okay. The child cannot clean up its own stuff. The parent, when it starts executing again, it doesn't just execute and continue on, what first thing it does is it gets rid of all that extra stuff that the child had to use, the address space and stuff like that. Then once it's done cleaning up after its child, then it continues on with its own whatever it was doing. Okay. So if we look at a state transition diagram, right, is if you have a new process, right, it can be runnable ready, but it's not running yet. Okay. It could be suspended because it may need to wait for certain things to happen before it can start running, right? So it'll stop there, right? Or it can just, like it says, it can stay from this runnable. It's ready. It wants to go. It wants to do stuff, right? If it transitions into the running state, so now it is actually executing on the kernel, actually executing in the system, okay? It may get preempted or rescheduled, like if another process comes in and needs to run on the kernel, it can preempt it, right? Or it may need to get information from the user. It may need to get some input of some kind, right? But for the most part, it's going to spend a lot of its time doing this. It's going to spend a lot of time running. Now, it could be forced to wait. Now, a wait call could be if it's a parent process and it's called some other process in order to hold on just a second. All right, so where was I? Okay, so if it's running, it may need to wait, like if it's a parent process and it forked to a child and it's waiting and it's waiting and it's waiting, and then finally the child comes back, right? Then it can be runnable again. It will clean up that child structure and then continue running itself, right? And then but once it's done with all of its work, once it's done running, it will exit, and it will, assuming, right, that it's a child process, right, that it will become a zombie, or even the main process will become a zombie, and something above it will have to get rid of the system or something like that. We'll have to get rid of it, right? But it'll become a zombie. It can't clean up itself. And the reason why is because it's done running. It's done doing anything. So in this case, a zombie is not like in the movies or in a TV series where they're walking around doing stuff. A zombie here is just it's dead. It's gone. It's not able to execute anything. Right? And so it cannot clean up itself. So what has to happen is something above it, something else that's running, has to clean up the zombie stuff, right? The memory stuff. Right? So again, that was an explanation using the diagram. If you want to see a more detailed kind of what some of these different process states and flags and what they mean is here. There's this table down here. I believe this should be available in your HTML resources. If not, I can print these, I can save these to PDF and upload them. So just let me know if these are available in HTML resources. All right, so again, I said you could see what current processes were running. We could do that using the PS command, the process command. Right. And so when we run the PS command, we'll see what processes are running, who is running it, what kind of resources it's using, what is its state, and stuff, the current process state, and stuff like that. Okay. So if we run the PS here, options aux, AUX would be listing all processes. Okay. So running that PS command here, we see some of these different processes that are running. Okay. We see the user who's running it. We see what type of resources, CPU and memory is using. We see when did it start, how long has it been running, all this kind of information. Okay. Process ID, a PID tells us what the process ID, just like with our user IDs, our user names versus our user IDs, UIDs, the process is going to have its own process ID, and that's how it's going to be identified, right? Not by its name, but by its process ID. So here are some different processes here. Now, some different things, some processes in brackets are scheduled. Scheduled kernel threads. Zombies will show up as exiting or defunct, their process state. Okay, will be seen as exiting or defunct. PS will display once, but we can use this top for being able to see repetitive, so it's for it to keep repeating to see the process, because it's only going to give us, if the PS command on its own is only going to give us an immediate what is running right now. Okay, and then we can also see parent-child relationships. So if we look through, again, this is a quiz that that I uploaded to that class materials folder. So again, take a look at that, see what you can remember from this, and yeah. But I'm really more interested in getting to these practices, these guided exercises, because I think those are much more useful for you guys to be able to learn this material. Okay. You know, actually, what I do want to do is, like I said, I don't want to rush through this. So what I want, but I do want to go ahead and give some what's it called, practical instruction as well. So I do want to go, what I'll do is I will go back to chapter 6 so that we can go through some of the practice sessions on the VM machine. Again, assuming that this virtual machine comes up and runs today. Let me start up the CentOS, and then I'll share it as soon as it starts up. Let's see here. Don't do this to me. It does not need to be able to show this, does it? So okay. It looks like it's not going to allow me to share the screen of the CentOS, unfortunately. It looks like it's like lots of things are just not wanting to work well today. So what we'll do is we will, I know this is going to delay us in getting things done as in a timely fashion for this semester. So what we'll do is we will pick up with, and I need to make a note, in case I forget, can somebody be in charge of reminding me that what we'll do is next week, the very first thing is we will go through chapter 6, the guided practices on the CentOS system, because I really think that file permissions, changing file permissions and changing group and user ownership and understanding how default permissions work, those are really some of the most important parts of what we do here, of what system administration is about. So we'll start off next week with the CentOS stuff. For some reason, it's not letting me share that screen. It'll let me share my entire computer screen, but then when I do that, the mouse gets messed up when I try to get into the CentOS virtual machine. So we'll just have to not do that today. And in fact, you know, I really think that we've gone through enough material for today. So especially with everything not working quite as well as it normally does. So what we'll do is we'll end there for today. Again, I apologize for technical difficulties. Yeah, so midterm, let's see. Good question, Nita. Let me see. They sent us a message about midterms. What was it? Did they make an announcement? They were supposed to make an announcement on things like the Google Classroom page or something like that. Let's see. Yeah, the dates are, so this is a third year class. So I believe are the first week for this, the first set of weeks. Let's see. First and third. So the first and the third year classes, their exams will be held the 7th through the 11th of December. What it will have to be is, it will have to be some type of online, probably like a Microsoft Forms type of exam, where what I can do is I will try to make it as similar to last year's exam as possible, not in terms of actual questions, but just in terms of the way that it was done. So for example, what you'll be asked to do will be stuff like, say, write what kind of command could do this, you know, and kind of like if you've done the homework, if you've been working on the homework on both assignment 1, if you finished that, and which hopefully all of you did, and if you are working on assignment 2, then for the most part you should be fairly well prepared for the types of stuff that will be coming at you for the exam. The plan is to have you be able to look at, so for example, yeah, I could share actually. Let me share like this, for example. Let me share this so you can see it, what I'm looking at. So this is from chapter 6. Okay. So this is from chapter 6, the first quiz, right, from chapter 6. You know, you could imagine that I would ask you questions like this as well. So I would ask you questions related to write the command to change this directory to this other directory, write the command to create this file, write the command. Also make sure that you understand, one of the things I really want you guys to understand as far as some of the writing of commands is how to use pipelines and how to use the T command as well. So for one of the questions in the first assignment, that was specifically really looking for how many of you recognize that what it was asking you to do was to not only display something, but also write it to a file. And so that what I wanted you to be able to know was, okay, that means I need to use a pipeline and I need to use a T command. Okay, so you needed to be able to do that using one command. So I'll have some questions like that. You would also be asked to look at some listing like this, where you would have a set of users and what groups they belong to, and then a set of files and some of their permissions, and be able to tell me, okay, who is allowed to, say for example, who's allowed to read our file 1? Well, let's see. Fred can read R file 1. Anybody in the Flintstone group can read R file 1. All others can read R file. Everybody can read R file 1. The really tricky one would be, so where a fun question would come in would be here in this L file 2. And the reason why is because you could say, I would say, you know, my friend Wilma here, she's actually that's not what I was saying, but is if the permissions were swapped. Sorry. But one of the ones that I'll do will be stuff like where somebody will have only read access for the owner level, but read and write access for the group level. And you'll need to understand that the owner, even though they're the owner, and even though they may be in the group that the file belongs to, they still can't write to it if these file permissions are reversed. Let me go back, because an example of that was actually in the main text on this one. That's why I bring it up. So like this here. So like this file here, L file 2. So Lucy, nope, wrong way. Okay, so here, this example here, actually, yes. So Lucy can read and write the file because she's the user owner. People in the Ricardo group can read the file only. So Ricky can only read the file. But weirdly enough, Ethel and Fred can both read and write to the file. And that seems like it shouldn't be that way, but it is. And the reason why is because permissions are granted to the user first. If you're the user that owns the file, you get whatever the user permissions are, even if they're less than other permissions. If you're not the user, but you're in the group, then you get the group permissions, even if they are less than what the others get. And then finally, if you're not the user or the group, then you get whatever the other permissions are. Okay. So I want you guys to make sure, because I will absolutely give you an example of something like this, where I will say, you know, my friend Ricky and my friend Fred, let's say coworker, person I'm working with, Ricky tried to access a file the other day and he couldn't, but Fred was able to. And Ricky was surprised because he's part of the group that is the group owner of the file, so he couldn't figure out why he couldn't access it. And so we need to explain to Ricky, the reason you can't access that file is because the group level permissions are more restrictive than the other owner, the other non-user, non-group permissions. Okay. So that would be a kind of question I would give you there. Okay. So like I said, I think that if I share what my plan will be I will share I'll share a copy of last year's midterm exam that I gave. So I'll put that in the class materials folder, and you guys take a look at that and see what you think. This year's exam, again, in terms of style and in terms of subject matter, should be pretty similar. So I'll try to do it as best as I can on Microsoft Forms. Okay, but that's what it looks like we're going to have to do. Is it'll be that first week of December, or I guess not first full week of December, but what's the date on that? The 7th through 11th of December, so second week of December is when these exams should be. Okay, so thank you, good question. Anybody else? Okay, all right, again, I'm sorry for the technical difficulties. Hopefully next week, unfortunately I think maybe next week will have to be a little bit longer of a class than I was originally planning, so sorry about that. But other than that, I'll see you guys next week, and have a good weekend. Iitatele.